Alright, hi everyone, and welcome to my Chemistry Basics study guide where we're basically going to be going over measurements, SI units, and significant figures. So, long story short, chemistry is the foundation of pretty much every facet of our world around us. And chemistry really is the basis of everything, and so the measurements that we use within chemistry are extremely important to understand. So the first thing I'm going to be going over is something called scientific notation. It's a format that a lot of times we'll use in chemistry to simplify things because it makes long numbers a lot easier to portray. So also within chemistry we use a specific set of units referred to as the SI units. This is a standardized set of units, consists of mass, length, time, and temperature, in which the mass will predominantly be measured in kilograms with that little symbol of kg, length will be in meters with that small lowercase m, and time in seconds with the lowercase s. Temperature will utilize something called Kelvin with a capital K. Alright, so now let's talk a little bit about prefixes, because this is something that I know a lot of students have trouble with. Oftentimes you'll be asked to memorize these prefixes, but it's not for no reason. It's very important to understand and memorize all of the different prefixes as they appear here. I'm going to show you a really easy tool to navigate through conversions, but at the very least you do need to memorize these values and know which prefix is associated with which notation. Alright, so the quick tool that we'll be using is called King Henry's daughter usually drinks chocolate milk. And really you just need to memorize the first letter of each word because it represents each prefix. And you write it out as so. So if we're converting 5 milligrams to kilograms, I'm going to walk this through here, but within the study guide it does go step by step. So we'll write out the acronym, King Henry's daughter usually drinks chocolate milk. We'll circle the unit that we're starting at, which are milligrams, and then we'll circle the unit that we want to get to, which is kilograms. And we'll see how many jumps we must take to get from our starting unit to our final unit. So we'll travel all the way to the left, and we'll note that we took 6 jumps in the left-hand direction. So what this tells us is this is the direction that we're going to move our decimal place. So we'll drop the decimal by 5 and continue by replicating what we just did, jumping 6 times to the left, and then dropping the decimal down, putting zeros into all of the little jumps. So our final answer is 0.000005 kilograms. And you'll see here that that checks out, but this is just a pretty quick way to navigate simple conversions between prefixes. Alright, what about dimensional analysis? Because this is a really difficult topic that a lot of people struggle with, and if this is you, you're definitely not alone. Really what we're doing here is we're just building. So it's kind of like a puzzle where each step should serve to cancel out the units of the step previously. So if we have 25 kilograms and we want to get to a new set of units, the kilograms in that next step should be on the bottom. And what I mean by that is essentially the 25 kilograms that we start with is technically over 1. So the 25 would be on top and the 1 is on the bottom. So we want to cancel the kilograms, meaning in the next step it should be on the bottom. And you'll see they do cancel appropriately, leaving grams alone. However, if we want to keep going and we want to end up in milligrams, we do need to continue by adding an additional step. So noting here that we've now filled in the prefixes, which is why it's important to memorize them. So 10 to the third will be our kilograms, but we want to get to milligrams in this problem, so we keep going. So same deal here. If we want to get rid of the grams this time around, the next step, or step 3, it will have the grams on the bottom. But the main gist here is that we can't go straight from kilograms to milligrams. Instead, we have to take a quick little pit stop at that central unit of grams. So that is why we need to have 3 steps rather than just 2. So now we can make sure that everything will cancel appropriately and we'll be left with milligrams at the very end. And then we fill in our prefixes, so for milligrams it's going to be 10 to the negative third. kilograms is 10 to the positive third. So that's how they differ. Now we just divide. So the way that I teach people to do this is multiply everything across the top and then everything across the bottom. So it should be 25 times 10 to the third times 1 on top, and then 1 times 1 times 10 to the negative third on the bottom, and then we just divide. Makes it a little bit simpler and make sure that you really don't forget anything along the way. So we get a very large number, which makes sense because milligrams are very small. You'll probably be asked to report this in scientific notation. So you can see here that this would end up being 2.5 times 10 to the 7th milligrams. All right, so what about significant figures? This is another really tricky topic that I know people do tend to struggle with often. So the first thing we're going to do is we're always going to start counting, and if we are met with a number that's 0, we're not going to count that as a significant figure until we reach a digit that is not 0. The number that starts with 0, we won't count until we encounter a non-zero digit, and these are called our leading zeros. Leading zeros do not count towards the ultimate significant figure total. So you'll see here 0.003. Those first 3 zeros don't count, so that's just one sig fig. In the opposite end of the spectrum, if there are zeros hanging out at the end of the number, so they'd be after that 3, we do count them. And these are called our lagging zeros. So as you'll see here, I put 2 more zeros after the 3, and those do contribute. So in this one, we'd have 3 sig figs. All right, so let's look at this example. If we have 0.0005, those first 3 zeros won't count because there are leading zeros. However, in this example, if we have an additional 0 hanging out after the 5, that one will count because that's a lagging 0, and we don't want to leave those behind. So those ones do contribute. Now that next one, it starts right off the bat with a number that's not 0, so we count that one, and then we keep going. So this is 4 sig figs. And this last one is almost like a sandwich. So everything will count, starting with a non-zero digit, ending with a non-zero digit. They're all going to count. Not too horrible, but there are more rules. So in addition when we're dealing with operations such as addition and subtraction, it's a little bit different than what I'm going to go over with multiplication and division, which is the least number of significant figures. So they do differ. So in this example, we're dealing with addition. So we'll line them up, add them up, and then we'll look at our final answer. So individually, we want to look at each of the numbers that we're adding and see which one has the least number of decimal places, because that's what we will round our final answer to. So 12.11, we have 2 decimal places. 3.6 only has 1. So this will dictate what we round to, because it's the least. We will round to 1 decimal place in our final answer. So our final answer is 118.1 with 1 decimal place. Number 2, we're looking at multiplication. This one, we just want the number of sig figs, not decimals. So they differ, and this is important to know. So the least number of sig. Thank you so much, and if this helped you, please like and subscribe and reach out with any additional questions that you might have. Thank you very much.